So welcome everybody to this latest video on 162 Maths, and in this video we're going over the AQA Level 2 Certificate Further Maths June 2023 Paper 2, which is the calculator paper. Now before we get started working through this paper, a little reminder that I'll include a link to the paper and a question breakdown, so if there are any questions that you're not sure about, you can see what topic it refers to, and you can also see what topic you need to revise or maybe review if you have made any mistakes. And I'll also include a link to the 162 Maths contents page, which gives you easy access to lessons, topic tests, audits and other exam paper walkthroughs. Now if I have made any mistakes in this particular paper, please do check out the description and I'll add any corrections there as well. So let's get started on question 1. So question 1 says solve 8d minus 3 over 3d minus 7 equals 5 over 2. Now for this all we need to do is just cross multiply. So I multiply 5 by the denominator of the algebraic fraction. So we've got 5 lots of 3d minus 7, and I'm going to end up with 2 lots of 8d minus 3. Then all we then need to do is expand the brackets. So I'm going to get 15d minus 35 equals 16d minus 6. And then if I take the smallest d over to the other side, I'm going to end up with minus 35 equals d minus 6, take the 6 over and end up with d equals minus 29, and there is my value of d. Moving on to question 2, it says the first 4 terms of a linear sequence are 15, 18.5, 22, 25.5, and the question is asking us to work out the expression for the nth term. So for this all we need to do is find the difference between the term to term, which in this case is plus 3.5. So that means that 3.5dn is going to be in the formula. D's come from the previous question. And then from this, what I then need to do is establish what do I need to do to get from 3.5 to 15. Well, I need to add 11.5. And there is our nth term. Then for question 2b, it says a different linear sequence has an nth term of 318 minus 9n. Work out the value of the first negative term in the sequence. Now for this, what we need to do is make the nth term, which is 318 minus 9n, and we're looking for the first negative number, so we're going to make that less than 0. So solving this, what we end up with, 318 is less than 9n, and then 318 divided by 9 is less than n. Now if I type that into my calculator, which I can easily do because as this is a calculator paper, I'm going to get 35.3, and we're going to end up with is less than n. And so for this, what we then need to do is basically see whether we're going to use n equals 35 or n equals 36. So if I substitute n equals 35, end up with 318 minus 9n, and we swap the n with 35, and if I type that into my calculator, which I'm going to do now, I end up with an answer of 3. So that's not going to be my negative term. So if I just double check, 318 minus 9 lots of 36, that's going to give me an answer of minus 6. So the first term is going to be our 36th term, which is minus 6. Moving on to question 3, it says work out the values of t and u. So for this, what we need to do is we need to multiply out the matrix. Now for this, remember, we do this multiplied by this first. So I'm going to end up with 3 lots of 1 plus 5 lots of 4. And then for the second row numbers, I'm going to do, let's use this, I'm going to use that multiplied by that. So I'm going to get 1u plus 2 times 4, and looking at what that equals, that's going to equal t, and that's going to equal 6. So then solving these, or simplifying I should say, what we end up with is we end up with 3 plus 20 equals t. So t is going to equal 23, and then from this we end up with u plus 8 equals 6. So u is going to equal minus 2. So my t value is 23 and my u value is minus 2. Moving on to question 4, it says the line passes through P at 1k and q at r6, where k and r are constants. The midpoint of PQ has an x coordinate of 5 and the gradient of the line is 2. And the question is asking us to work out the value of k. So let's first of all look at the midpoint. So to work out the midpoint of a coordinate, I need to use this formula. Divided by 2. So looking at the midpoint of these two coordinates, I add the two x coordinates, that's going to be 1 plus r over 6 and k, 6 plus k, or k plus 6 over 2. I don't know where that 6 has come from, so let me just get rid of it. Over 2. And it says that the x coordinate is 5, so this bit here equals 5. So what we've got is we've got 1 plus r over 2 equals 5. So 1 plus r equals 10. So r must equal 9. So now that I've got the value of r, I now need to work with the gradient. Now to work out the gradient of m is equal to y2 minus y1 over x2 minus x1. So substituting the coordinates in, I've got 6 and r, and I've got 1, a k, and 1. And it tells us that that equals 2. Now I know that r equals 9, so I can replace that with 9. So what I end up with is k, 6 minus k over 8 equals 2. So 6 minus k equals 16. And then from this we get minus k equals 10. So k equals minus 10. And there is my value of k. Let's take a minus 10 there. Then moving on to question 5, it says y equals 0.5 x to the power 4. Work out the value of x for which the rate of change of y with respect to x is 6.75. Now whenever you see the word rate of change, you always need to think of differentiation. So for this, what we need to do is we need to differentiate this expression. So we've got dy over dx. And again, the rule for differentiation, move the power to the front, lower the power by 1. So 4 times 0.5 is 2, and lowering the power by 1 gives us this. Now it tells us that we want the gradient, the rate of change, to equal 6.75. So 2x cubed equals 6.75. So then solving this for x, we get that x cubed is going to equal 6.75 divided by 2, which gives me 3.375, and then x equals the cube root of 3.375, which when I type that into my calculator, I get an answer of 1.5. Moving on to question 6, it says the equation of a circle is x plus 7 squared plus y minus 4 squared equals 36. Complete these statements. The coordinates of the centre of the circle are. Now to work out the x coordinate, what I need to do is find the value of x that makes this bracket here equal to 0. So x needs to be minus 7. Then to find the y coordinate, I'm looking for the value of y that makes that bracket equal to 0. That's going to be positive 4. And then this value here is the radius squared. So if r squared equals 36, the radius is going to equal 6. It can't equal minus 6 because you can't, radius is a length and you can't have negative length. So the radius there is positive 6. Moving on to question 7, it says here is a sketch of the curve y equals ax squared plus bx plus c, where a, b and c are constants. The curve intersects the x-axis at minus 4, 0 and p at 0. The turning point of the turning point has an x ordinate of 0.5, and the question is asking us to work out the value of p. So for this, as this point here is the midpoint, then all we need to do for p is work out the distance here. So the difference between minus 4 and 0.5 is 4.5. So that means that this distance here must also equal 4.5. So p equals 4.5 plus 0.5. So p equals 5. It then says solve ax squared plus bx plus c. So first things first, what we need to do is find the equation of the curve. So as one of the roots is minus 4 and the other root is 5, then that means that in order to get root of minus 4, x plus 4 must be one of the brackets, and the other bracket is going to be x minus 5, and that is greater than 0. Now this bit here represents the curve, and we're wanting where the curve is above 0. So what we're wanting is this region here and this region here. So in order to get this region here, that is where x is less than minus 4, and this region here is where x is greater than 5. So our answer for 7b needs to be that x is less than minus 4.5 and x is greater than 5. Now moving on to question 8, it says ABC is a triangle with a perpendicular height of AD. The area of ABC is 25 square centimetres and the ratio of B to D to D to C is 2 to 3. Work out the size of angle W. So for this, what we need to do is, as we've got the perpendicular height and we don't know what the base is, we can use this information. I'm going to use area equals base times height divided by 2 to try and work out what BC is. So for this, we know that the height is 4, we know that the base is BC, and we know that the area is 25. So using this information, what we've got is 4 times BC is divided by 2 is equal to 25. So that means that 4BC is equal to 50. And dividing that by 4, we get BC equals 12.5 centimetres. So let's just put a little bubble around that. So we know that this total distance here is 12.5. Now using the ratio of 2 to 3, well, we do 12.5 equals 5 parts. So that means that 1 part is going to equal 2.5. So from this, what we can then do is we can then work out what BD is. So BD is 2 parts, which is going to equal 5 centimetres, and DC is 3 parts. So that's going to be 3 times 2.5, which is 7.5 centimetres. Now the question is asking us to work out angle W. So if I take this triangle here, which angle W is part of, we know that this length here is 4, and we now worked out that this length here is 7.5. So using SOHCAHTOA trig, we've got that tan W equals 4 over 7.5. So that means W is going to equal the inverse tan of 4 over 7.5. And then typing that all into my calculator, I get an answer of 28.1 degrees, and that's to 1 decimal place. Now, depending on rounding, the answer would accept any answer between 27.9 to 28.4. So as long as you've done the right method, as long as your answer between those two regions, you would be absolutely fine. So looking at question 9, it says the dimensions of a cuboid are given in centimetres. The total length of all 12 edges is 300 centimetres, and for part A it says show that y equals 75 minus 6x. Now for this particular question, what we need to know is that we're going to end up with 4 of each of those sides of those edges. So I've got 4 lots of 3x. So the edges is 4 lots of 3x. And I'm going to have 4 lots of 2x, and I'm going to have 4 lots of x plus 2y. So write an expression for all the edges. That's going to be 12x plus 8x plus 4x plus 8y, and that all equals 300. So simplifying this side here, what I end up with is I'm going to end up with 24x plus 8y equals 300. And then all that's left for me to do is make y the subject. So I take the 24 over to the other side. So 8y equals 300 minus 24x. And then dividing everything by 8, we end up with 300 minus 24x over 8. Now what I then want to do is divide everything by 4. So divide everything on the top by 4. Oh, I forgot and divide everything by here by 4, in which what I'm going to end up with 300 divided by 4 is 75. 24 divided by 4 is 6. That's going to be 6x. And 8 divided by 4 is 2. And that is what they wanted me to prove. Then moving on to question 9b, it says the volume of the cuboid is v cubic centimeters. Show that v equals 450x squared minus 30x cubed. Now to work out the volume, what I need to do is multiply the 3 dimensions together. So if I multiply the 3 dimensions together, what I end up with is v is going to equal 3x multiplied by 2x multiplied by x plus 2y. So if I first of all multiply these two things here together, I'm going to end up with 6x squared, and I need to multiply that by x plus 2y. So expanding them out, what do I get? Well, I'm going to end up with 6x cubed plus 6 times 2, which is 2x squared. No, it's going to be 12x squared y. Now at this moment in time you might be thinking to yourself, well, that doesn't equal the same, but you need to remember that we need to get rid of this y. So from this y, what we then remember is that y equals 75 minus 6x over 2. So if I swap this for this, what does that become? Well, that's going to become 6x cubed plus 12 lots of x squared, and then we're going to multiply that by 75 minus 6x over 2. So then multiplying this by this, then what we end up with is we're going to end up with 6x cubed plus, now 12 times 75, well, that's going to give me an answer of, and let's just quickly type that into my calculator. So 12 times 75 gives me 900. So that's 900 x squared minus 6 times 12, which is 72, and that's x cubed, and that's all divided by 2. So then simplifying this, we can divide both the things by 2, so what that ends up with is 6x cubed plus half of 900 is 450 x squared, half of 72 is 36 x cubed. Simplifying all of that, we get 450x squared minus 30x cubed, and that is what v equals. And that is what they wanted me to show. Moving on to question 9c, it says use calculus to work out the maximum value of v as x varies. So for this, what we need to do is first of all therefore find dv over dx. So we know that v equals 450x squared minus 30x cubed. So if I then work out dv over dx, that's going to be 900x minus 90x squared. And what I'm wanting to do is to find the maximum value. So for this, what I need to do is make that equal to 0. So 900x minus 90x squared is equal to 0. And so at max dv over dx equals 0. And then from this, I don't want to take the 90x over to the side because I'm going to lose a potential value of x. So for this, what I then need to do is factorize. So I could take a 90x out, I should say, in which I'm going to end up with 10 minus x equals 0. So either x equals 0 or x equals 10. Now the last thing for me to do is, now I know that they're stationary at these 2 points, is that the maximum is when the second derivative is less than 0. So to work out the second derivative of 900x, this we get dv d squared v over dx squared is equal to, and that's going to be 900 minus 180x. Now looking at these two values, when I substitute x equals 0, the second derivative is going to be greater than 0, so the only possible value it can be is when x equals 10. And that's the only way that I'm going to get my second derivative to be less than 0. Moving on to question 10, it says the line K has the equation of 4x minus 5y equals 17, and the line L passes through the points 3, 6 and minus 5, 16. Tick with a tick the correct statement about lines K and L, and it says the lines are parallel, the lines are perpendicular, and the lines are neither parallel or perpendicular. We need to show some working out as well. So for this, what we need to do is first of all find the gradient of each of those lines. So for this, my m value is when we make y the subject. So I'm going to end up with 4x minus 17 equals 5y. So then I end up with 4 divided by 5x minus 17 over 5 equals y. So the gradient of line K is going to be 4/5. So then finding out the gradient of this line here, so m is going to be the difference in the y, so that's 16 minus 6, over the difference in the x, that's minus 5 minus 3. And what that becomes is 10 over minus 8, and that's minus 5 over 4. So as you can see, that one is the negative reciprocal of the other, so the two lines are perpendicular. And we can say as m of L multiplied m of K equals minus 1. Moving on to question 11, it says expand and simplify fully 2x cubed minus 9 multiplied by 3x squared plus 4 plus x lots of x minus 4 squared. So for this, there's a fair amount of things that we actually need to do, and we probably need to do this separately. So let's have a look at, first of all, simplifying these two. So using my loops, if I multiply those out, I'm going to end up with 2x, or 2 times 3 is 6, and x to the power of 3 times x to the power of 2 gives me x to the power of 5. And then we end up with 2x cubed times 4 gives me 8x to the power of 3. Then minus 9 times 3x squared is going to give me minus 27x squared. And minus 9 times positive 4 is going to give me minus 36. Now I then need to add, and then working with this, well, x minus, let's not do it there, let's do it somewhere else. So x minus 4 squared is going to be x squared minus 8x plus 16, and I want x lots of that, so that's going to be x lots of x squared minus 8x plus 16. Then simplifying this, I end up with x cubed minus 8x squared plus 16x. So that if I move this pink and just rewrite it again, and then all I then need to do is collect the like terms. So how many x to the power of 5s have I got? Well, I've got 6 of those. I've got no x to the power of 4, so that squashes it. Then in terms of things with x cubed, well, I've got those two things there. So adding those two up, I get 9x cubed. Looking at the x squareds, I've got minus 27 and minus 8, and that's going to give me minus 35x squared. Then things with single x's is just plus 16x, and any constants is just minus 36, and that there is my final answer. Moving on to question 12, let's just zoom out so we can see it all in its entirety, and of course it's going to reset, so let's just drag all of this back down, which we get this question here, and it's saying that VABCD is a pyramid. The square horizontal base ABCD has a length side of 15 centimeters. V is directly above the center X of the base. VA is 28 centimeters, and the question is asking us to work out the size of the angle that VA makes with ABCD. Now VA is this line here, and so what we're wanting to work out is what this angle here is. So this is the angle that I'm wanting. And I always say that it's always important that you make that first. So if I then turn that into a triangle, this is the triangle that I need to work out the dimensions of. So looking at the fact that we know that AB is a square base, that means that this is 15. So if I then take this triangle here, that what I end up with is A, C, and B. This is 15, this is 15, and this is what I wanted to work out. So I can use Pythagoras to work out what x is. So x squared equals 15 squared plus 15 squared. So x equals, and that's going to give me 450. Oh, that's not square root just yet. And so that's going to give me 450. So x equals the square root of 450. So therefore, a to x is going to equal root 450 divided by 2. So if I then draw this orange triangle, or what's trying to look like a triangle, this is A, this is V, and this is x. I now know that this length here of AX is root 450 divided by 2. Now, I also know that A to V is 28. So using this triangle and using SOHCAHTOA trig, so if I just label this as y, then this is my hypotenuse, this is my adjacent, so I need to use cos. So cos y equals, and it's going to be root 450 over 2, all divided by 28. So what that then means, and let me just do this over here so I've got more space. So that means that y is going to equal the inverse cos of root 450 divided by 2 all over 28. Now if you're not sure about how to enter that on the calculator, let me just enter that in now. Let's wait for the calculator to load. And there we go. So we enter first inverse cos. I then open my bracket, which is done, and then I set up my fraction. Now I want a fraction at the top, so I press that again. So the numerator is root 450, scroll down, and that's a 2, and then I scroll down again, and that's going to give me 28. Scroll across, and close the bracket, press equals, and I get an answer of y equals, let me just load that up again, 67.74. So 67.74 degrees, and that's to 2 decimal places. Now depending on your rounding, they would accept any answer between 66.9 degrees to 68.4 degrees. So as long as your answer is between that range and you've used the correct method, then that would be absolutely fine. Moving on to question 13, let's just zoom in so we can see it a bit more clearer on the screen. It says circle the expression equivalent to 3x to the power of minus 7. So for this, what we've got is 3x to the power of minus 7 means 3 times x to the power of minus 7. A negative fraction, or negative power, means the reciprocal. So that's 3 lots of 1 over x7. So what I'm looking for is 3 over x to the power 7, which is our fourth option. Moving on to 13b, it says simplify fully 12w to the power of 8 divided by 4w cubed all squared. So for this, what we need to do is to simplify the denominator. So what that then becomes is 12w to the 8 over, now we square the number so that becomes 16, and then we multiply the powers. So that's going to be w to the power of 6. Now from this, what we then want to do is simplify the two terms. So what goes into both 12 and 16, that's going to be 4. So we can change that to a 3, change that to a 4. We can then take away the powers. So what we're left with is 3w squared divided by 4, and there is my final answer. Or alternatively, you could write it as a decimal as 0.75 w squared. So any of those two answers will be absolutely fine. Moving on to 13c, it says the square root of y multiplied by the cube root of y is equal to the c root of y to the power of d, where c and d are positive integers. And the question is asking us to work out the least possible values of c and d. Well, for this, what we need to do is we need to rewrite this using indices. So looking at the yellow term, we can, anything that's being square rooted, we can write to the power of a half. Anything being cube rooted, we can write that to the power of a third. Now this is what we then need to simplify. So what do we do when we're multiplying? the indices, we add the powers. So that's going to be y to the power of a half plus a third. I can then stick that in my calculator and I get y equals 5/6. And so what is my value if I compare that to y to the power of dc, or to be dc it should be. Now I wrote cd, am I using that to rub it out? And to the dc, so c equals 6 and d equals 5. Moving on to question 14, it says simplify fully, and I've got this algebraic fraction and we are multiplying. So for this, what you want to try and do is, I would always try and factorize where possible. So we can factorize this length here. So a squared plus 6a minus 16 is equal to, and that's going to be a plus 8, a minus 2. I can simplify 8 minus 4a, because that's going to become 4 lots of 2 minus a, and everything else can't be simplified. Now for this question is really sneaky, because it's all about this here. It's all about this that we then need to rewrite. So if I substitute those two things in first, what do we get? Well, I'm going to end up with 15a squared over a plus 8, a minus 2, multiplied by 4 lots of 2 minus a over 3a. Now at this moment in time, nothing cancels out with those two individual fractions, but where the key comes with this question is rewriting this. Now obviously what we're wanting to do is to cancel out the brackets. Now I can rewrite this as minus 1, and I can write this now. We want the a to be negative, so that's going to be there, and I want the 2 to be positive, so that's going to be minus 2. So this, what I've highlighted in yellow, is the same as this. Now if I multiplied that by 4, I'm going to end up with minus 4 and then bracket a minus 2. So rather than writing this, I'm going to swap that for this. So what the fraction then looks like is 15a squared over a plus 8, a minus 2, multiplied by minus 4, a minus 2 over 3a. Now from this, there's a couple of things we can simplify. Now, more common enough that I would assume most students would multiply the numerators and multiply the denominators. So if we do just that, 15 times minus 4 is minus 60, and I get, and that's going to be, then we look at a squared times a is a cubed, and let's not jump ahead too far. Then we get a squared a minus 2 all over 3a, a plus 8, a minus 2. Now from this, what we can then do is cancel things out. So that cancels with this. The 3 changes that to a 20, and this a cancels with that a. So what we're left with? Well, we're left with minus 20 over a plus 8, and that there is my simplified fraction. Now moving on to question 15, it says the function g is given by g of x equals a times b to the power of x, where a and b are constants. The domain of the function is minus 1 and 2, inclusive of those numbers. P is at a coordinate of 0 to the half, and q is 1, 3 over 2. Are points on the graph where y equals g of x, and the question is asking us to work out the range of the function. So for this, what we're wanting to do is between this range here is the range is this here. So that is the range that we're wanting. Now for this, what we need to do is using P is what we need to do is find the equation of the line. That's what our game is. So using P, I know that at P, x equals 0 and y equals a half. So substituting those numbers in, So I've got a half equals a times b to the naught, and that is what I've got. Now simplifying this, b to the naught, anything to the power of 0 is 1. So that means that a equals 0.5. So that's one of the values found. So then using Q, in which this is my x value and this is my y value, we get 3 over 2 equals a times b to the power of 1. Now anything to the power of 1 is just itself, so that's just a times b equals 3 over 2. We know that a equals 0.5, so 3 over 2 equals a half times b. So to work out b, it's going to be 3 over 2 divided by 1 over 2, and if I type that into my calculator, I get a b value of 3. Now that I've got my value of a and b, I can then work out the equation of the line. So y equals 0.5 multiplied by 3 to the power of x, and that is the equation of the line. Now what I'm wanting is to use that values to then find out what the respective y values are. So for this, to find the domain, but we know that the range of x is -1 to 3. So if we take when x equals 1, that's going to give me the lowest range. So when x equals -1, y is going to equal 0.5 times 3 to the power of -1. And if I type that into my calculator, I get a y value of a sixth. Now when x equals 2, which is the biggest value that I could choose, this value of 2 is going to give me what this value here is. So substituting that into the equation of the line, I get y equals 0.5 multiplied by 3, this time squared. Typing that all into my calculator, I get a y value of, I don't know why it slipped there, so let's just move up a little bit. We get a y value of 4.5, and this is my range. So to work out the range of y, it's going to be between a sixth and 4.5, and it can equal those numbers, so we just put our equal sign, and there is my answer. Now instead of writing y, just remember that we're writing g of x because that's what it's asked us to find. Moving on to question 16, let's just zoom in so we can see it a bit clearer on the screen. So question 16 says 2x minus 3 is a factor of 6x cubed minus 25x squared plus 28x minus 6. Solve 6x cubed minus 25x squared plus 28x minus 6 equals 0. Give all solutions to the exact values. So for this, what we need to do is, as we know that 2x minus 3 is a factor, we're going to use our factor theorem to then work out and try and factorize this polynomial. So we've got 6x cubed minus 25x squared plus 28x minus 6, and that can be written as 2x minus 3 multiplied by my quadratic expression, which I'm going to write it as ax squared plus bx plus c. Now what I then need to do is expand this out. And again, just to save a bit of time, I'm just going to, actually I'll just do it now. So what we end up with is 2ax squared plus 2bx and squared minus or plus 2cx. Then multiplying everything by minus 3, we get minus 3ax squared minus 3bx minus 3c. And then adding all of that together, we're going to get 2ax squared plus 2b minus 3ax squared plus 2c minus 3bx minus 3c. I've just factorized the things with ax. If you write it as a long list, that's not a problem. Now what we now need to do is compare the coefficients to try and find out what a, b and c are. So looking at the coefficients of x cubed, on the left hand side we've got 6, and on the right hand side we've got 2a. So that means that a equals 3. So that's one of my values. Then looking at the coefficients of x squared, on the left hand side we've got minus 25, and on the right hand side we've got 2b minus 3a. Now from that, what I can then do is, I know that a equals 3, so minus 25 equals 2b minus 9. Take the 9 over to the other side and end up with minus 16 equals 2b, so therefore b equals minus 8. Then looking at the constant is minus 6 on the left hand side and 3c on the right hand side, in which therefore c equals positive 2. So what we've then got is we've got 2x minus 3, and I'm going to end up with 3x squared minus 8x plus 2. Now from this, what we then need to do is, because it's saying x the exact values, what I then need to do is use the quadratic formula. So it's not going to factorize, I can tell you that now, because otherwise it won't. Exact values usually implies using surds. So using the quadratic formula on this, we get a equals 3, b equals minus 8, and c equals 2. And I'm going to assume that you know how to do that. So the solutions for this bracket is x equals 3 over 2. And then solving this quadratic using the quadratic formula, I'm going to get a value of 4 plus root 10 over 3, or minus 4 plus it should be 4 minus root 10 over 3. That's a 10, not a 16. And so the three values are x equals 3 over 2, 4 plus root 10 over 3, and 4 minus root 10 over 3. And there are my three solutions. Moving on to question 17, it says the function h is given by h of x equals ax multiplied by 3x squared minus 2 plus 5x, where a is a positive constant. H is an increasing function for all values of x. Work out the possible values of a. Now, if it's an increasing function, so if h is an increasing function, then of x, then dy over dx must be greater or equal to 0. Now for this, what we then need to do is to differentiate this expression here. Now to do that, what I'm going to suggest that you do is expand the brackets to make that easier to work with. So what we end up with is 3ax cubed minus 2ax plus 5x. So then simplifying the expression, we can't simplify that any further. So then what we want to do is work out dh over dx by differentiating this expression. So moving the power to the front, we get 9ax squared. This then just turns into 2a, and that's what we end up with. And we've got plus 5. Now from this, we know that that's then 9ax squared minus 2a plus 5 has got to be greater or equal to 0. Now, looking at this expression, you might be thinking to yourself, well, how am I supposed to solve this when I've got a 9a and x? I've got two letters. Well, how we solve it is actually looking at it in this form. Now, what we're wanting is we're wanting this to be greater or equal to 0. Now, this here, this bit here, so if a is always positive, then this must be positive. So in other words, that it must be greater than 0 or 0. So the only thing that can be equal to 0 is going to be this. So all I then need to solve is minus 2a plus 5 is greater or equal to 0. Now solving this, we take the 5 over to the other side, so that becomes minus 5, and so a, because we're dividing by a negative number, we need to flip the inequality, and that becomes 5 over 2, and that there is one of the answers. So this, in terms of the range of the possible values of a, it's going to be between 0 and 5/2. Because the smallest value, just to go by where the zeros come from, the smallest this can be is going to be 0 for all values of x, because a is a positive integer. Moving on to question 18, it says here is a sketch of y equals cos x, and it says y for all values of x from 0 to 360. Alpha is an obtuse angle measured in degrees. Cos alpha equals minus k, where k is a positive constant, and it says tick 2 boxes to show the expressions for x where cos x equals minus k. Now, for this, what we're needing to do is we recognize that this distance here is alpha. Now, for this is the point that I'm looking for, and this is the point for the other answer. Now, to work out this other answer, what I need to do, well, one way of doing that is to work out this distance here. And to work that out, this distance here, that's going to be 360 minus alpha, which is one of the options, and it is this option here. Now, to work out the next possible angle, what I need to do is continue this curve. So it looks like this. Now, at this point here, that is going to be 360 plus 90, which is 450, and this is the other value. Now, to find that other value, I need to work out this distance here, and that distance there is also alpha. So to work out this point here, I need to do 360 plus alpha, which is the other value. So the box I need to tick then is the last two, well, the boxes I need to tick are the bottom two options. Now for question 18b, it says circle the expression where sin x equals minus k. So what we've got here is a 270 shift. So it's going to be 360 plus a minus 270, which gives us 90. So the one that we want to circle is 90 plus alpha. Now moving on to question 19, it says in these simultaneous equations k is a positive constant, and the question is asking us to solve the simultaneous equation, give your answers in their simplest form in terms of k. Now for this, what we need to do is we need to use the substitution method. So wherever I see a y, I'm going to swap that with 2kx. Now if I do that, what I end up with is 3x plus 4 lots of 2kx, and that equals k. So all I've done is just substitute it into that equation there. And what I now need to do is make k the subject. Oh, sorry, x the subject. So make x the subject. So if I expand the brackets, I get 3x plus 8kx equals k. I want to factorize this, so I get x out. So I've got 3 plus 8k equals k. So therefore x equals k over 3 plus 8k, and that is one of my solutions. So now that we've found the value of x, all that's left for us to do is find the value of y. Now to find the value of y, what I now need to do is basically use this expression here. So if I change colour, so using y equals 2kx, well, we know that x equals this expression here, so I've got y equals 2k multiplied by k over 3 plus 8k. Now you might be thinking to yourself, how on earth do I multiply this? Well, if I turn the 2k into a fraction, all I've then got to do is multiply the top, so that's going to be 2k squared over 3 plus 8k. And does anything simplify? No, it doesn't. So that there is my value of y. So my answer for x is this, and my answer for y is that. Moving on to question 20, it says show that 2 sine cubed x plus 2 sine x cos squared x plus 5 tan x cos x simplifies to p sine x, where p is a constant. So for this, what we need to do is we need to use the trig identities. Now the trig identities are as follows. So we know that tan x equals sine x over cos x, and we also know that cos squared x is equal to sine x squared, or 1 minus sine x squared. Now for this, the reason why I'm using these is because the final answer, we only want sine x. So what you want to try and do in your substitutions with your trig identities is find something that involves sine x squared. But these are the trig identities I'm going to be using. So I'm going to keep the 2 sine cubed x. So that's 2 sine cubed x plus 2 sine x. Now instead of using cos squared x, I'm going to use this instead. So let's just put that in brackets. Plus 5 lots. Instead of writing tan, I'm going to write sine x over cos x. And I've got cos x there. Now from this, what we can then do, well, I can't do anything with about the first term, so let's just write that out. Now multiplying out this, I end up with 2 sine x minus, and that's going to be 2 sine cubed x, and then the cos x's cancel out, so that's just going to be plus 5 sine x. Now from this, the 2 sine cubed x cancel out, so all that I'm left with is 2 sine x plus 5 sine x, which then simplifies to give me 7 sine x, which therefore means that p equals 7. Now you don't need to write p equals 7. This would be your final answer because I just want to write in the form of something multiplied by sine x. Moving on to question 21, we get A, B, C, D, E are points on a circle with centre O, and the question is asking us to find the value of x. Now, for this particular question, what we need to establish is that in this, although it's not obvious, well, we can see straight away we've got an isosceles triangle. So if this angle here is 2x, then this angle here is also going to be 2x. So I can work out this angle as being 180 minus 2x over 2. Now I can simplify that further by dividing everything by 2, and that's going to equal 90 minus x. So that is what this bit here equals. Now, in terms of the other two shapes, what you need to recognize is that this is a arrowhead. Now, although it may not look like it, it is an arrowhead. So this angle here, if I just write that in green, this green angle is twice the size of 7x. That's going to be 14x, which therefore means that this angle here is going to be 360 minus 14x. Now, once you've established that, I can then get rid of this green marking and do the exact same for this. So this blue angle is going to be twice the size of that. So that blue angle there is 12x. So that means that this angle here is going to be 360 minus 12x because angles are around a point. So if I just get rid of that blue, and as you can see, what we've got there is we have got, let me just edit the colouring there, is what we've got is we've now got expression for that full circle. So using all of this, what we know is 360 minus 14x plus 90 minus x plus, that should be a 3 there, let me just add that 3 there, plus 360 minus 12x equals 360. So from this, let's try now simplify all and collect the like terms of all of this, in which what we end up with is 900 minus 30x, and that equals 360. I take the 30x over to this side, in which we end up with 900 equals 30x plus 360. Take the 360 over to this side, so that disappears, and I've got 900 take away 360, which is 540 equals 30x. So x equals 540 divided by 30, which gives me an answer of x equals 18. Then finally, moving on to our last question, it says 5-digit integers are made using 1, 2, 7, 8, 9. For each integer, all the digits are used exactly once. The integers are greater than 40,000 and odd. How many different integers can be made? You must show you're working out. So for this to be true, what we need to do is the 5-digit number must start with 7, 8, or 9. And for it to be odd, it needs to end in either 1, 7, or 9. Now, let's have a look at the combinations of this. Well, starting with 7, I've got 3 possible numbers, and that needs to start in either end in a 1, or it needs to end in a... can't end in a 7 because that's already been used, so that ends in a 9. Now then, moving on to the next digit of 8, with the 3 numbers, that either ends in a 1, or it ends in a 7, or it's going to end in a 9. Then moving on to 9, that's either going to end in a 1, it's either going to end up with a 7. Now, in order to work out those middle numbers, the combination, so all in all, we've got 7 combinations. Now, in terms of those middle 3 numbers, well, to work out the middle 3 numbers, combos, well, in terms of the first number, we've got a choice of 3. The second number, we've got a choice of 2 numbers, and then the middle number, we've only got a choice of 1. So 3 times 2 times 1 equals 6. So the total number of combos is just simply going to be 7 times 6, which is 42. And there is my final answer for that. Now, if you look in the description, I'll include the grade boundaries not only for this paper, but if you've also done paper 1, you can combine your scores and see what your overall grade would be for those 2 papers. Or if you've just done this paper, you can see what you'd get for just this single paper.